Once we know the empirical formula, how do we go from an empirical formula to a molecular formula? All right, so what we have to do to go between the empirical formula and the molecular formula is we have to have knowledge of what the molar mass of the whole compound is. What we do is we determine the molar mass of the empirical formula. Then we look at the ratio of the molar mass of the compound to the molar mass of the empirical formula. We take the actual molar mass divided by the empirical formula molar mass. We get a whole number, and then we can multiply the empirical formula by that whole number. How do we determine these molar masses? Well, as I mentioned, with empirical formulas, we have all sorts of techniques that we can use to determine the elemental analysis of our compounds. To get a molar mass of the compound, we have a different set of techniques that we can use. So we can do things like mass spectrometry, and mass spectrometry will let us figure out what the molar mass of our actual compound is. All right. So, acetic acid, vinegar. We want to know what the molecular formula is, given that the molar mass of vinegar, of acetic acid, is about 60 grams per mole. So what I do is I figure out the molar mass of my empirical formula. Okay, so my empirical formula is given here. It's CH2O, so do 12.01 plus 2 times 1.008 plus 16, and I get 30.026. All right, and so I'm going to take the molar mass of my actual compound divided by the molar mass of that empirical formula, and I'm going to get 2. So I know that my molecular formula is a multiple of 2 of the empirical formula. So I'm going to take 2 times my CH2O, and I'll get C2H4O2. And indeed, that is vinegar. I can rewrite acetic acid as this, CH3COOH. All right, 4 hydrogens, 2 carbons, 2 oxygens. I can also do this. And that's what the structure of it looks like. And again, we have 2 carbons, 4 hydrogens, and 2 oxygens. Okay. Now, for the most part, though, when we look at these, we're going to have to do some other calculations too. You know, a lot of the time now, we have the molar mass of the compound, and we have some empirical formula data. I have a compound of sulfur and nitrogen. It's 69.6% sulfur by mass. If it's only sulfur and nitrogen, 100 minus 69.6 gives me my nitrogen. So, all right. I think I'm going to have to... Let's see here. Did I give myself... Okay, I think I gave myself 2 slides on this one, yeah. All right, so I'm going to take my mass percent sulfur, 69.6 grams of sulfur, 1 mole of sulfur, and 32.07 grams of sulfur. I get 2.17 moles of sulfur. Now, for my nitrogen, I take 100% of the compound minus 69.6% sulfur gives me 30.4% nitrogen. Okay? So then we take our 30.4% nitrogen times 1 mole and 14.01 grams, and we get 2.169, which gives me 2.17. Okay, so I have S 2.17 ec. Nitrogen 2.17. Okay, so there's my empirical formula. My empirical formula is SN. Okay? So we figured out our empirical formula. Now we want to know what the molecular formula is. So we need the molar mass of the empirical formula. So we're going to take 32.07 plus 14.01, and we get 46.08. All right, and then we take the molar mass of the compound, the 184, divided by the 46.08, and we get 4. So we're going to multiply our whole empirical formula by 4. We're going to get S4, N4. Okay? All right. We'll do one more. All right, so now we have a percent composition for this fluorocarbonyl hypofluorite, carbon, oxygen, and fluorine. So first step, let's determine our empirical formula. One mole of carbon and 12.01. We're going to get 1.21 moles of carbon. Our mass percent of oxygen becomes our grams, so 39.0 grams of oxygen. 1 mole of oxygen in 16 grams. We'll get 2.44. And then we will get 46.3 grams of fluorine. 1 mole of fluorine in 19 grams. We get 2.43. Okay, so we'll get carbon 1.21, oxygen 2.44, fluorine 2.43. We'll divide by the 1.21. And we end up with CO2F2 as our empirical formula. Okay? So now we got to take our empirical formula and what we know about the molar mass of our compound and figure out our molecular formula. Okay, so our empirical formula was CO2F2. All right, so now we need the molar mass of empirical formula. So we'll get 12.01 plus 2 times 16 plus 2 times 19. And we will get 82.01. Okay, our actual compound is 82. Our empirical formula is 82.01. So divided by each other, we get 1. So our molecular formula is also CO2F2. All right, so that's how we go from our empirical formula to our molecular formula.